Hello students, this is Ms. Cave with a lesson on solving and graphing inequalities. Today we're going to focus on one-step inequalities, and then we will move on to two-step inequalities. So this SOL, let's write that on there as well. This is our Virginia SOL 7.13 that we're learning. And so last week we started looking at the different symbols for inequality, so we're going to quickly review that. This sign here means greater than. This other sign means less than. Over here on the right, we have kind of like an equal sign underneath the greater than sign. So this is greater than or equal to. And then this one, same thing, but it's less than or equal to. So we discussed on Friday how inequalities are different from equations because inequalities have multiple solutions. That's important to remember. We have more than one solution. So we have all the numbers that are greater than something, all the numbers that are less than, all the numbers that are greater than or equal to, or all the numbers that are less than or equal to, whereas equations have one answer. So if the answer, we talked about the height for the Chick-fil-A play place, your height x equals 54, that wouldn't make much sense because only somebody who was 54 inches could enter the play place, where we would include any kid that's below 54 inches. So we have an inequality here. So we're going to now practice, we're going to go on from just understanding the language of inequalities and then talk about how we're going to solve them. Now, the nice thing about inequalities is that we solve them just like we solve equations. So if you know how to solve equations that we've been practicing, you apply that to inequalities. But you know, with equations, you keep the equation balanced, right? As you do things to both sides. With an inequality, you're keeping the inequality unbalanced. Because this side here, it's telling us that x plus 3 is greater than 7. So whenever I do something to the left, I also do it to the right. So let's go ahead and practice solving this first one. X plus 3 is greater than 7. And just like with the equations, I want you guys to draw a line where you have the inequality sign so that we can solve it. Now this is a one-step inequality. So if you look here on the left, x plus 3 is greater than 7. How do I get rid of a positive 3? You take 3 away. Josh, are you writing all this down? You take 3 away. But remember, when I take something away from the side with the variable, I'm going to do the same thing on the other side. And again, I'm going to circle my variable because that's what I'm trying to isolate. So then x is greater than what? What's 7 minus 3? 4. So x is greater than 4. So notice that you don't put equals 4. It's telling us that x is greater than 4. So when you're graphing, we're going to go on to the graphing. If I want to show this on a graph, I'm going to put the number. This is how I'm going to teach you guys how to do graphs. I'm just going to use 3 of the numbers on this graph. I'm going to put the number that it says x is greater than in the middle. So I'm going to put the 4, okay? And then I'm going to write the number to the right and the number to the left. So I'm going to write 3, the one that comes before 3, and I'm going to write 5, the number that comes after 5, just so I know where I am on the number line. I know that I have increments of 1 whole. Now, to show that a number is greater than 4, could I fill in a dot above 4? Could it be 4 if it says greater than 4? No. So what I'm going to use here to show that it's greater than 4 is I'm going to put an open circle above 4. Because I'm saying that the values that would make this inequality true, all of those values should be greater than 4, but not 4. So that's how you graph it. You graph it with an open circle, and because it's greater than, you're going to go to the right. So now what I'm going to do is I'm going to choose a number from the solutions on the graph to substitute and check. So what's a number that's greater than 4 that I could use to check? 5. Okay, so I'm going to substitute. So I'm just doing x plus 3 is greater than 7. I'm going to see if I've done this correctly. I'm going to substitute 5. Let's see if that works. 5 plus 3 greater than 7. What's 5 plus 3? 8. Is 8 greater than 7? Yes, so this is going to be check. It works. What's another number that I could use that's greater than 4? From the graph, a number that's greater than 4. There are other numbers here, we just didn't label them. 6, okay. So let's try that. X plus 3 is greater than 7. Let's try 6. 6 plus 3 is greater than 7. 9 is greater than 7. Does it work? Yes. So the next part says explain the solution in words. So explain the solution in words. So what I'm doing is I'm taking x is greater than 4 and I'm explaining that in words. So there's a couple of different ways. We could say all numbers greater than 4. We could also say all numbers above 4. But do you see how that matches? The x represents, because we have more than one number, like with an equation, we would say the number is 4. But here we're representing our solution with all numbers that are greater than 4. Does anybody have a question on that first one? All right, let's go ahead down to the next one. And we have a little bit different. We have 4m is less than or equal to 12. So we're going to copy down our inequality up here. 4m less than or equal to 12. And again, I'm going to put my line down the middle. I'm going to circle my variable. What's my variable? M is my variable. And 4 times m, right? The product of 4 and a number is less than or equal to 12. So how do I undo product? What do I do to the product to get rid of the 4? Divide. I'm going to divide both sides by 4. Okay, so when I divide by 4, m is less than or equal to, what's 12 divided by 4? 3. See, isn't this easy so far? It's just like equations, and now these are one step. We're spending 2 days on one step, but you'll see there's something that happens with negatives, but we'll look at that tomorrow. Today we're going to focus just on the positive numbers. It's Monday, so. Okay, so we're going to graph it. So I'm going to go onto my graph, and I'm going to put my 3 in the middle. I'm going to put 4. I'm going to put 2. I could go ahead and put all the numbers if I wanted to. Maybe I will. Right? I could put them all in. I just want you guys to get in the habit of putting the number in the middle. And when we do these on pencil paper where you don't have a graph, I'm going to require that you give me 3 numbers on the number line. That's it. And we'll do that tomorrow. When you guys do, half of you will be doing IXL, and half of you will be working with me to add some more examples in your notebook. All right. So let's look at this. This says that m is less than or equal to 3. So could I include 3 as part of my solution set? Yes, because it says less than or what? Equal to. So it could be 3. So what am I going to do with that circle? I'm going to fill it in because it could be 3. That equal right there tells me it could be 3 or anything. It goes this way. You look at the arrow. It goes to the left. Anything less than 3. 3 or anything less than 3. So we can choose our solutions. 4m is less than or equal to 12. I'm going to plug in 3. 4 times 3 less than or equal to 12. Is 12 less than or equal to 12? Is it? Is 12 less than or equal to 12? Yes, so I check it. What's another solution that would work? Look at our number line. What's another solution that would work? 2? Okay. So I'm going to put in 4m less than or equal to 12. 4 times 2 less than or equal to 12. 8 is 8 less than or equal to 12. Yes. So explaining the solution in words would be m is less than or equal to 3. So I'm trying to think of different ways to say this besides the ones that we've been talking about, greater than or less than. We'll say the solution is at most 3. It's less than or equal to, so that means that it's at most 3. So it's no bigger than 3. It could be 3, but at most it's 3. So we're going to vary our vocabulary a little bit so that we're looking at different ways we could say less than or equal to. And we'll be looking more at those words in the next lesson. All right, we've got a few more examples on the other side. So we're going to move over there. Are we ready? You can go ahead and look at the next one. The x plus 5 is less than 8. And try solving that. So we'll move there now. So I'd like you to go ahead and try this example here. We are going to go ahead in a moment. We are going to pause the video while you try this example. Let's go ahead and pause the video. Okay, so let's go over this inequality. X plus 5 is less than 8. Solve it just like an equation. We're trying to isolate the variable, which is x. We're going to subtract 5 from both sides, and x is less than 3. When we graph this, we're saying that it's less than 3. All values less than 3. So I'm going to put a 3 in the middle of my number line, and I'm going to list the two numbers, one to the left, one to the right. Is 3 itself part of the solution set? Would 3 work? Is 3 less than 3? No, it's not. So you're going to do an open circle. It can't be 3, but it's anything less than 3. You're going to draw your arrow that direction. And so now let's pick a number. And again, I'm just going to go ahead and fill in the rest of my number line. I'm going to choose a number from the solutions to substitute and check. Now this time, watch, I'm going to actually pick a different number. Let me show you what happens if you're wrong. Because sometimes people draw the arrow the wrong direction, and this is how you're going to catch yourself. So I'm actually going to pick a number. I'm going to pick 5 this time. Okay, so I'm going to say x plus 5 is less than 8, and I'm going to choose 5. It's outside of our solution set, but I'm going to see, so you guys can see what happens when you get it wrong. So 5 plus 5 is 10. Is 10 less than 8? No, so you're going to put a big X there. X, it's wrong. So if you do it wrong, like let's say I originally put my arrow this way and I put in 5 for my check, I'll know that I put my arrow in the wrong direction. Let's pick a number that will work. How about 0? Will 0 work? Is 0 less than 3? 0 works. So I'm going to put in 0 plus 5 is less than 8. 5 is less than 8, and this one checks. So we're going to explain our solution in words. Our solution set is x is less than 3, so it's going to be all numbers under 3. That's another way you could say it. Under or below 3. All right, what I would like for you guys to do is go ahead and try these next 2 inequalities. You're going to try these next 2. What I want you to do is to copy and solve them, graph them, substitute and check, and explain in words. So you need to have this completed for me tomorrow. So you need to have these 2 problems, and we'll go over these 2 problems in class together as a class before we do the next part of our lesson. All right, that's the end of our video lesson for One Step Inequalities for today. Signing out.